moving right along. Our next speaker, if you were going to get somebody from the world of education to talk about how to use gamification to transform that industry, which is, of course, one of the world's largest industries, you couldn't choose a better person than Robert Torres. Robert is the program manager at the Bill and Melinda Gates Foundation, focused on issues of higher education. He helped co-found one of the world's first game-based schools, Quest to Learn, in New York City, and completed some of the most important research on that very interesting learning game called Game Star Mechanic. And so it's my pleasure to introduce Robert Torres. Thank you, sir. Thank you, thank you.
Ooh, it is bright up here. Good morning, everyone. So I should be looking there. I lead, like Gabe said, a portfolio at the Gates Foundation where I get to look around the country for top game designers and education experts and learning scientists to create learning games. So it's a pretty cool job. And today I'm going to tell you a little bit about that work, some of the things we're investing in, some of them which include Will Wright's work. But before doing that, I just want to tell you how I even wound up in this space. So I grew up a pretty poor kid. I know not pretty, but poor kid in Brooklyn. And I actually wound up making a movie for HBO about my life's experience, Nuyorican Dream. And the movie was a meditation on poverty as a system, right? So looking with my family about at our condition as a system in which we operate and in which we have actually some agency, like Will Wright said earlier. By the way, speaking after Will Wright, I have to say, sharing the stage with you is amazing because Will, as for many of us, has informed so much of my work, so it's really an honor. I also then was, after college, a teacher and then went on to be a school principal of a school that I designed in New York City with a group of teachers. So I was really always into working with my fellow teachers. So we went off and did our own thing and created a school. And that was really fascinating work to me. And so I created a consulting firm that went on to design 30 schools in New York City. And all along, my interest in this work has really been about the design of systems. Like, what does it mean to actually create effective learning systems? And it turns out that that's what games really are, right? The funny thing is that for those schools that we created in New York, a lot of the small schools, so it turned out that the kids were doing well. We were graduating more kids out of high school, and they were mostly high schools. But the instruction that was happening in the schools was really not that great. So what kids were being asked to do in these schools was not really that rigorous, was not really asking kids to do complex problem solving. And so what we saw was that kids were pretty bored in a lot of these schools. And a lot of that was, so a lot of the schools started with a lot of innovation, and over time, what happened was that the schools succumbed to the assessment regime of the country, right? So that the exams and the testing regimes, especially with NCLB, would ultimately make the innovations of those schools sort of fade away as the curriculum was designed around tests. So a lot of my work at the Gates Foundation around games tackles this issue of assessments, as I'll talk about a little bit. But I wanted, the work that we do at the Gates Foundation is really about eradicating poverty worldwide, right? And in the US, we do that through education, through various programs in education. So I want to just put up these statistics because they are, in fact, so dire, right? We have 95% of kids in most cities saying that they want to go to college, but what we get is about 20% of kids who actually graduate from high school prepared to go to college. So it's pretty abysmal, right? The crisis is real. And yet, and so this is sort of the output of that system. And yet, what we are also seeing are these statistics, which are pretty astonishing, that Black and Latino kids, youth ages 11 to 18 are spending that much time engaged in media. And 97% of kids today are playing video games. This may be a number that a lot of you know. You know, I did that work in the schools, and the results of that work, it's funny, in education, something that we learn a lot about as teachers and people who lead schools is a lot about teaching, but we learn not so much about learning, right? So we're actually trained to teach, but we're not that well trained to actually know something about what learning is. And it's an interesting phenomenon that actually wound me up leaving the work that I was doing with school design and going in to get a PhD in a field called the learning sciences. The learning sciences is a field that it's about 30 years old and is a confluence of various fields: computer science, neuroscience, education. And so it's a really interesting space. And what we began to see was that in that field, in the research there, that games actually represented a lot of the principles that we were seeing were actually good for learning. And I'll talk a little bit about those. So what is it about games? And this is the stuff that we were discovering through our research in the learning sciences. So, and you know, some of this may be refreshers for many of you if you're game designers in the room. But what we are seeing in our research in the learning sciences is that games really are allow us to be in these places where we're learning to be versus learning about, so that we can actually step into a game and learn to be a biochemist or a physicist versus learning about those things, which is what we do in school. And games are also these possibility spaces, as Will says, you know, spaces to experiment, fail, and try again. And if you think about just these simple notions, right, that's what games do, and imagine what education does, they're actually polar opposites, right? Schools are not designed for us in places where we go tinker. They're just not. I mean, we should do that, but that's not what we do here in the US anyway. And games are these immersive design systems. So what we were seeing is that principles of good games were actually principles of good learning. And it's how I sort of, I mean, it helped that I grew up as a gamer, but when I went to get my PhD in the learning sciences, it helped that I had, you know, that I had those experiences. So a quick word about systems, because I keep using that term. There are three archetypes of systems, if you will, and they are technological, social, and natural. And what we're seeing is that the core design elements of a game, which are goals, rules, components, core mechanics, and some games, like SimCity, are more open-ended, and the player may set goals, and so it's, but most good games have a goal state, a win condition, a set of rules, components, components meaning the game pieces, the stuff in the games, and also it also includes the people who are going to play the games, the core mechanics, the behaviors that one takes on to move through a game, and then the space or the context. And it turns out if you know, those of us who are interested in creating gameful or gamified or game-based experiences, it's the interaction of these elements that give rise to certain conditions that we might call play, right? It's the interaction of these things that actually give rise to certain conditions. And so games in particular are a kind of social learning system, right? And what we see that the things that actually make that sort of define play are the conditions that rise out of these systems. And Will actually talked about some of these earlier. This kind of notion of sense of place, a sense of relevance. I know why I'm doing what I'm doing in a game, right? And again, these are very, if we think about the design of school and what goes on in schools, this is a pretty far reach, right? So we try and fund games at the foundation that are really taking these things into account. So Gabe mentioned Quest to Learn. The last school that I designed, I was lucky enough to work with a group of people, Katie Salin, and a number of teachers to create this school. So here in this school in New York City, and I encourage you to go to the website, it's a pretty awesome place where the entire curriculum is designed around the notion of a game. So you move through missions and quests to move through the curriculum. Systems thinking defines the entire curriculum. So for every piece of content that you tackle, you're either building or decomposing a system so that you really get a sense of systemic reasoning, and game design is also a big part of the curriculum. So I encourage you to go to Quest to Learn and see what we're doing there. Just a super quick overview of this field that's quickly evolving. And I should say that the games and learning field is in its infancy. In fact, our gamification world, right? We're really in our infancy in this work. And so it's almost a week from now, I'm sure my talk may be a little different just because things are happening so quickly. And so what that means is that we're really at an R&D phase, and in my own portfolio, there are 17 different game development projects and research, and which are all attached to a research project. But I wanted to just give you a quick overview. In the 1980s, I would say that the games and learning field really started in earnest with the work at MIT with Seymour Papert. And that had some starts and stops. And in the 2000s, with a book written by Jim G, it had a resurgence. This wonderful book by Jim G, What Games Have to Teach Us About Learning and Literacy, which offered actually 36 principles that are embedded in game. I tried to narrow them down to the 3 that I gave you. And also the MacArthur Foundation in the 2000s put in tens of millions of dollars. In fact, the total amount around digital media and learning with a big focus on games, they put in $85 million in about 2005, 2006 to launch this field. And sometime in 2006 or so, what we realized was, gosh, games may be really interesting tools for learning, and we yet had very little research. But what we discovered then was that, gosh, they're really interesting tools for assessment, right? And assessment is actually, like I said earlier, many of the innovations in the country sort of succumb to the assessment. Assessment is essentially the engine that defines what happens in classrooms. So my work and our work at the foundation and across various universities that we work with, as well as some game design companies, is really asking this question. So if you played Halo on hard, as Jim G likes to say, if you played Halo on hard, do you have to take an exam to see that you actually know how to play Halo? No. So might we actually embed assessment mechanics within games where we're capturing data in situ, right? Where we're actually capturing data as you move. And that's one of the big reasons why we can also actually do this kind of work, because of the copious amounts of data that games collect and deliver to players and to teachers potentially in a very granular way. So for the work that I do, there are overall 5 design requirements. So when I'm looking to the field to see where we might invest, there are 5 general design requirements. One is assessment of application. So if you're going to design a game, can you get your players to actually apply skills and knowledge to solve a complex problem? So that's not how we do exams now. It's not how we do testing. It's not how we do learning, where you actually have to apply algebraic skill and knowledge, say, to solve an engineering problem. So one of the design requirements that in your game world, you have to do this. Common Core and Next Generation Science Standards, if you don't know what those are the new standards that the country has recently, many states in the country have adopted which is going to drive also the next generation of assessments. That you assess complex skills. So we want to be able to, we can create the mechanics within games that we capture data on the degree to which you collaborate well, to which you can problem solve, to which you can synthesize information. So assess complex skills is one thing. That you really know something about engagement. That you are concerned with making stuff irresistible, right? That you can actually, and this is why we work with game designers to do this, because they've solved this unlike anyone else. Immediate feedback, right? And data analytics, that we can embed the kind of mechanics in games that collect granular data, and most good games do that. So our working hypothesis in our design with these 5 design requirements is that at the intersection of these 2 things of high cognitive demand and high engagement is mastery. That you actually, that is how expertise is actually developed, right? That it's at the intersection of these 2 things. Just a quick slide. I'm not going to go into all of these, but I will feature a couple. These are some of the investments we're making. Institute of Play is also the creator of Quest to Learn, and the creator of Glass Lab, which I'm going to talk about a little bit. And I'm going to feature refraction first. So refraction is being developed by the team that created Fold It. So many of you may have heard of Fold It. Actually, can I just get a sense? How many people know Fold It? Great. Okay. Usually I go to conferences, I'll ask that question like 2 people. This is a game where, a crowdsourcing game really, where you issue challenges to gamers, scientists issue challenges to gamers, and gamers have been, as you can see from this slide, doing the unimaginable, the remarkable, right? So we're working with this team to use a similar approach. And what makes Fold It really interesting is that it's really an assessment engine that assesses the degrees to which you can fold protein wells. There are about 17 skills that you need to learn to fold proteins well, and it adapts to your needs, and it puts you on these novice to expert trajectories along those skills, right? Really powerful, right? So it actually understands the player to the degree where it can actually adapt to it and give you suggestions. And so we're using that to create a fractions game, which is a pre-algebra game. And what you won't get a huge sense of the play experience in the video that I'm going to show you, because it's also very collaborative. There's a whole community piece to it, which we don't talk about. But what I will show you is the assessment behind how assessment happens and the kind of data that teachers and students get, and how it's highly adaptive. So a lot of our work, my overall, the umbrella under which my work falls is under personalized learning. So moving away from the one to the many model that we get in classrooms to the one-to-one. How do we really personalize educational experiences so that 30 kids in a classroom can be having 30 different experiences, depending on both, with their needs and their interests. So here's a little bit about Fold It. And again, this is about refraction. This is the Fold It team led by Zoran Popovic at the University of Washington. Let's see if the sound...
Refraction is a game about understanding fractions. Players must provide the right fraction of laser fuel to each spaceship on the board in order to save the creatures trapped inside. Players might need to split the lasers several times, or recombine them in creative ways. Initial studies have shown statistically significant learning gains on traditional validated math assessments after playing Refraction. The game has been played by over 300,000 people and has won 2 International Game Awards. Refraction is also a teaching and assessment tool. Its teacher control panel lets teachers access detailed information on students' performance on each Common Core concept. Using this information, teachers can customize the game by creating student-specific challenges targeting math concepts in a variety of ways. For example, by entering fractional expressions that are automatically converted into game levels. They can then assign those levels to the class or particular student, transforming homework into home play. While the students are playing the game, teachers can view mastery of key concepts across the students in a matrix. The matrix can show which students have achieved full mastery of certain math concepts, or it can serve to
So I'm gonna try to be to honor our time limits. So tell you quickly about this last example, which is GlassLab, a project at EA, which really is a groundbreaking, we think, collaboration between a set of different institutions, Institute of Play, EA. So the GlassLab is housed at EA down the road in Redwood City. And what it is a collaboration between game designers and psychometricians, or assessment scientists who are designing the assessment mechanics. The first game that we are working with in the lab is actually SimCity. So we have a SimCity EDU project where we are within SimCity coding and creating assessment mechanics so that we can see the kind of scientific reasoning and mathematical reasoning that kids are using as they move through the game. Which, for us, it's a real culmination of our work and really pushing the boundary on assessment innovation, as we see that is really the biggest lever we could pull to change education altogether. So what are we learning? I was hoping to unveil at this conference some real big data stats, but we're still a few weeks away. But I will reveal that we are, in our games, showing significant gains compared to traditional teaching methods. But this is also a big deal. With also a research firm down the road by Stanford, we have done a meta-analysis of 61,000 studies. It's actually almost 62,000. Who would have known that we actually have that many studies on games and learning now? And what we're seeing is this, that digital games are associated with significantly better cognitive competency outcomes compared to traditional methods. So this gives us tremendous confidence that we are moving in the right direction. I've been doing this for 10 years now, and I was like, if this study comes out, like, my career may be over, because we've been hypothesizing all along. And so this is really actually encouraging. It's awesome to be at this conference. Gabe, thanks for having me. It's awesome to be around people who are thinking about solving complex problems through playfulness. So with that, thank you.
Thank you so much. Awesome.